So chemical testing today is often too slow, too expensive, or offers limited information for fast real-world decision-making. And companies and municipalities need to know things like what kinds of chemicals are in the water, or what does this novel compound that we design, how does it interact with living cells? And traditional methods can often take weeks and thousands of dollars. At Built-In Bioassays, we changed that by genetically engineering algae with these built-in biosensors that can tell you things like what kinds of chemicals are in that sample, or how is this a compound acting inside the cell within under 24 hours.
A lot of research into the impacts of contaminants in the environment has moved towards cell-based assays because they don't require the use of a whole fish or a whole mouse or a rat. So it's more ethical, but it also is faster and cheaper. And we started moving towards that in my research lab here at the School of Freshwater Sciences. And through that process, Eric came in as a grad student and now postdoc, where he was investigating the impacts of different chemicals on these different types of cells. And I built from there, we started realizing that the cell-based assays could tell us quite a bit about what was in a particular sample and how it might impact organisms that were important for the environment.
This technology has utility for multiple sectors. For example, agrochemical developers can run screenings faster and they can kill bad candidates early on. Water utilities can identify emerging contaminants beyond a handful of things they already test for. And regulators can get richer mechanistic data beyond just simple yes-no toxicity. So ultimately, we really hope to accelerate chemical discovery while reducing risk for environmental and human health exposure. And that's a win across the ecosystem.
The UWM Research Foundation has been really integral to us building out our basic research into something that could potentially be commercialized. So whether it's from the I-Core program, which really takes researchers that are lab-based researchers into the world of commercialization and patents and how to talk to potential stakeholders, potential companies and investors, to then also funds that help us then further develop our research into products that might be useful in the marketplace. And then just general advice. The folks in the Research Foundation have been incredibly helpful and really guiding and mentoring us through this whole process.
So right now, we're continuing to develop and scale up our technology, as well as planning to prepare for potential pilot studies with partners. And it's exciting because we're still at the beginning, but the demand is there and the technology is coming along. We really hope to accelerate chemical discovery in a way that benefits industry, regulators, and ultimately the ecosystem. This isn't just another product for the sake of science or for the sake of commercialization, but really we developed it with the health and sustainability of our freshwater ecosystems in mind. And we really hope that our technology will contribute to that, as well as the well-being of society in general.
Ultimately, the goal with our company is to help in the creation of safe and sustainable chemicals that won't hurt the environment and can help companies, develop better products. And then also to evaluate which chemicals are out in the environment that may be causing harm, that we need to figure out where they're coming from, how to control them, et cetera. And so I think one of our goals in reaching out is to figure out what types of markets might also be interested in this type of project. We think that it has great potential to help many different industries and many municipalities and other types of organizations. And we would love to hear about any other potential partners that we could have in trying to figure out other uses for this particular product.